Hello students, welcome back. Let us continue with exercise 14.3 of chapter 14, question number 4. The length of 40 leaves of a plant are measured correct up to 1 millimeter and the data obtained is as follows. So here is the tabular representation of our data wherein we have the class intervals giving the length of leaves in millimeters and number of leaves. So there are 40 leaves out here and these are the frequencies. So when you add up the frequencies, you're going to get 40. Now on the basis of this data, we need to draw a histogram and answer these two questions. So first of all, to draw a histogram, we need continuous class intervals. But here, if you see, you have 126 out here in the first class, for example. The upper limit is 126 and the lower limit of the consecutive class is 127. So it is not continuous, right? There needs to be continuity. For example, if this was 126, this too should have been 126. So we see that there is a lot of discontinuity in this entire class interval list. Also, so what we are going to do is we are going to make the class intervals continuous to draw the histogram. Now the second thing is we need to find out whether the histogram is having bars of uniform width or varying widths. Why? Because in histograms, the width of the bars, it plays a very important role with respect to the frequencies. Why? Because if you have a histogram, see there are two types of histograms. Histograms with uniform width and histograms with varying width. So you can see there is a lot of difference in the width out here. They both are histograms. Now, since the width of the triangle, the width of the bars or the area of the bars are directly proportional to the frequency, then the length of the bars, they become proportional to the frequency. So we need to find out whether these bars are going to be that of uniform width or varying width. How do we find that out? By taking a look at the difference of upper limit and lower limit of each class. So let's check for class 1, 118 to 126. So 118, the difference of 126 and 118 would give you 8. Here as well, 135 minus 127 would give you 8. And if you check for each one of these, the difference is 8. That means here we are going to get a histogram of uniform width, where the bars are going to be of equal width. Therefore, the lengths of the bars are going to be directly proportional to the frequency, and we do not need to make any changes or calculation to draw the histogram. Just that we need continuous class intervals. So how do we calculate the continuous, how do we find out the continuous class intervals? We are going to take upper limit of any class and lower limit of the consecutive class. We are going to find their difference and divide it by 2. So what is the difference? It's 127 minus 126, which is 1. You can check even for 136 and 135. See, the difference here is 1, the difference here is 1, the difference here is 1, 1 and 1. So you divide by 2. So what do you get? 0.5. And then what do? Is we subtract 0.5 from all the lower limits of all the classes and add 0.5 to the upper limits of all the class intervals. So let's do this. Okay, so where do we do this? Let me do it here for you because we have the space to write the answer. I'll say to find continuous class intervals (127 minus 126) divide by 2 is going to be 1 divided by 2, which is equal to 0.5. So you're going to subtract 0.5 from, I'm just writing LL for lower limit of each class or class interval, and add 0.5 to upper limit, so UL of each class. Right? So now what we will do is we will write down the revised class intervals. So I'll say revised class intervals. So CI for class intervals. Now 118 minus 0.5 is going to be 117.5 up to 126.5, because we are adding 0.5 to this entire line and we are subtracting 0.5 from this entire line. So let's write this down. 117.5 to 126.5. Then again 126.5 to 135.5. Then 135.5 to 144.5. Then again 144.5 to 153.5. Then 153.5 to 162.5 and 162.5 to 171.5 and finally 171.5 to 180.5. So here again, if you see the difference between the upper limit and lower limit of each class, that's going to remain unchanged, that is going to be 8. Now we are going to use this table, this data out here on the x-axis and this data out here on the y-axis. So x-axis and y-axis. We aren't really going to use this because we have revised the class intervals to draw a histogram. So let's get started. I have my coordinate axis. Now, if you notice, we have the starting class as 117.5. It isn't really starting from 0. So what did we learn in histogram is that we are going to insert a kink. Kink is used to show a break. That there are classes, there are other numbering between 0 and the consecutive numbers. So let's get started. I have okay, so let us mark this now. I have 117.5. So what I'm going to do is I'm going to erase this section. I hope you've taken a note of it. If you haven't, please do. So 117.5, then I have 126.5, then I have 135.5, then there is 144.5, then 153.5, then 162.5, 171.5 and 180.5. And this can keep going on, but since our data ends over here, the class intervals end over here, I am just keeping it until 180.5. And on the y-axis, see, we have very small numbers from 2 being the lowest to 12 up to the largest. So we can take units of 1, right? So 1 millimeter, no, not 1 millimeter, it would be 1, 2, 3, because this is closest to 1 millimeter, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And let's write down the, let's label our x and y axis. So x axis I have, y axis I have number of leaves, and x axis I have length of leaves in millimeters. We'll fill in the scale later on. So let's get started with the histogram. So the first one is 117.5 to 126.5. The length is 3. So I'm going to draw a bar of 3 from 117.5 to 126.5. Then the other one, 126.5 to 135.5, I have the bar of length 5. So let's draw this. Then the other one is 9, which is in this class interval. So let's draw this. I have 9 out here. Then the other one is 12. So 12 is going to be here. It's a very long line and I'm doing it freehand. That's the reason it's going a little crooked. Please make sure you're using a scale to draw these lines or these bars. Then the other one is 5, which is in the class interval 153.5 to 162.5. So let's draw this. Again, it's 5, so it's going to be the same length as this one, right? So I'm drawing it using the same colored chalk, that is green, just to show that these both are of the same length. Then I have 4, which is in the class interval 162.5 to 171.5. So 4 is going to be here. And finally, the last frequency, which is 2. So this is the required histogram, and now what we will do is we will write down the scale. So on x-axis we have the length of leaves in millimeter. So that's going to be 8 millimeters on the x-axis because we have taken differences of 8, right? So 8 millimeters on x-axis, and on y-axis we have 1 leaf. Now looking at this histogram that we have, we need to answer 2 questions. The first one being, is there any other suitable graphical representation for the same data? Yes, we can draw a frequency polygon. Once we can draw a histogram, obviously we can draw a frequency polygon of the same data, which is much more simpler and less time consuming, right? So I'll say yes, frequency polygon. Then the third question, is it correct to conclude that the maximum number of leaves are 153 millimeters long, and why? So first of all, let's check the bar which is the tallest. So I get the tallest bar as this one, right? This yellow color one. So that is between 144.5 to 153.5. So now the data has been given in, it's not been given in decimal points. You have whole numbers out here. So first of all, it is this class, right? 144.5 to 153.5. So instead of taking this, first of all, it's not going to be just 153 millimeters. It's going to belong in this range. But the actual given data is not this one. We have modified this for the purpose of drawing our histogram. So instead of taking this, I'm going to say the leaves belong to this range, 145 millimeters to 153 millimeters. So is it correct to conclude that the maximum number of leaves are 153 millimeters long? So first you're going to say no. Always whenever they ask you a question, you should specify it as a yes or no, especially when they're asking you to specify if something is correct or not. So no, and then the reason that the maximum number of leaves are 145 millimeter to 153 millimeter long. So again, revising the last question, if you see the tallest leaf, the maximum number of leaves belongs to this category. So this category is coming under the range 144.5 to 153.5, right? This yellow bar, if you notice. So it's not just 153, it's a collection of two classes, two data, that is 144.5 and 153.5. But 144.5 to 153.5 is is what we have deduced just to draw the histogram. So we are going to actually take the class that has been already given to us, which is 145 to 153, and this is in millimeters. So I hope you've understood this question. Please take a look. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.